I'll share the screen. In the last lecture itself, we have started with the second section in that unit 1, and in overall syllabus, the unit 5. Name of this unit is functions, and as after sets we have studied relations. Same wise functions are there, little bit difference is there that we will see while learning. In this unit, contents are function types. Many types are there. We are going to see all those types of functions, then composition of functions, and then inverse functions. Okay, as we have seen compositions of relations also and inverse of relations also. Same like that, we are going to see these concepts about the functions also. We have taken little bit of introduction in the last session itself. What is a function? In mathematics, a function from a set X to a set Y is an assignment of an element of Y to each element of X. The set X is called as domain and the set Y is called as codomain of the function. As in the relation, domain and range are the terms. In functions, the terms are domain and codomain. Okay, and sometimes that codomain is also called as range. Okay, means no difference is there, but in case of functions it is called as domain and codomain. And meanwhile you can see, or in process of learning we may go through the term range in case of functions also. Okay, then functions were originally the idealization of a varying quantity depends on another quantity. For example, the position of a planet is a function of time. Okay, how the idea of functions is there in the relation. What is there? No any dependency is there. Okay, only the relation is there. But what is the function? One quantity is varying depending on the another quantity. That is nothing but the function. The example here given is the position of a planet is a function of time, because time to time the planets are going to change its position. Okay, and depending on that, what we can say is the position of a planet is a function of time. Many other examples also we can give in that case, as we have discussed at that time, that velocity and time are depending on each other. So function, acceleration, and as we from school time we are seeing the laws of motion. Yes or no? Newton's law, first law, second law, third law, like those are also defined in terms of functions. Okay, what is that formula? Can anybody recall? U is equal to AT. In that T is the particular time, is the acceleration, and U is the velocity given. Is it the first one? Is it the first law of motion? Am I correct? Because I'm not recalling now, miss. I'm not able to. That's why I'm asking. But I think it is the first law of motion. Is it one? Yes. Am I audible to you? Are you able to listen me? Okay. The concept of a function was formalized at the end of 19th century in terms of set theory, and this greatly enlarged the domains of application of the concept. A function is most often denoted by letters such as f, g, and h, and the value of a function f at an element x of domain is denoted by f of x. Okay, what we take it as a f of x. F of x is the function of x. Okay, that it is a varying, x is the varying quantity depending on this function. Okay, f of x. A function is uniquely represented by the set of all pairs x and f of x. What the ordered pair here is x and f of x, called the graph of the function. Functions can be represented with the graphs in the our plane. Okay, coordinates of a plane. So coordinates are x and f of x. F of x is y. X and y coordinates we have in the coordinate plane. So x and f of x are, suppose we have points, then we can plot them in the coordinate plane also. When the domain of and the codomain are sets of real numbers, each such pair may be thought of as the Cartesian coordinates of a point in the plane. The set of these points is called the graph of the function. It is a popular means of illustrating the function. Functions are easily understood with the help of graphs. Functions are widely used in science and in most fields of mathematics. It has been said that functions are the central objects of investigation in most fields of mathematics. Means it is the application of functions. It is used in science, yeah, and in most fields of mathematics. Means many fields are there which are in science and mathematics, in which these functions are used to evaluate some things. So it is called as central objects of investigation. Investigation is easier with the help of functions. Here what we can say is, if a variable y is so related to a variable x that whenever a numerical value is assigned to x, there is a rule according to which a unique value y is determined, and that then y is said to be function of the independent variable x. Okay, here variable is x. Okay, and whenever a numerical value is assigned to x, there is a rule according to which a unique value of y is determined. Some function is applied to x, and that f of x is nothing but the y, and this y is said to be function of the independent variable x. X is the varying quantity, and some function is applied on the x that we call it as f of x, and that is equal to y. That f of x is nothing but y. Okay, this relationship is commonly symbolized as y is equal to f of x. Here we can see y equal to f of x, which is said f of x. It is said like f of x. And y and x are related such that for every x, there is a unique value of y. For every x, there is a unique value of y. As x changes, y also changes. That is, f of x cannot have more than one value for the same x. If x is changing, then only the y is changing. If x is same, means x is 1, then y will not have more than one value to itself. Okay, means for x there is a fixed y is there. No other value of f of x or y will be there. F of x is nothing but y. Here we can see y equal to f of x. But this f of x is not having another value if we consider the same value of x. x ची व्हॅल्यू जी असेल त्याला एक युनिक व्हॅल्यू ऑफ y असणार आहे. x च्या व्हॅल्यूला 2 y च्या व्हॅल्यू not possible. Okay, for every x there will be unique value of y. For same x there will not be two values of y. To use the language of set theory, a function relates an element x to an element f of x in another set. What is there? To use the language of set theory, a function relates an element x to an element f of x in another set. Means what? A function relates an element x to an element f of x in another set. Means two sets are there. X is there and y is there. Y is nothing but f of x. Two different sets will be there. One will contain values of x and other will contain values of f of x. That is nothing but y. The set of values of x is called as domain of the function, and the set of values of f of x generated by the values in the domain is called as range of the function. Okay, same in this here we have seen that it is called as codomain, but it can also be called as range. Okay. In addition to f of x, other abbreviated symbols such as g of x and p of x are often used to represent functions of the independent variable x, especially when the nature of the function is unknown or unspecified. Okay, when the nature of the function is unknown or unspecified, what the symbols are there? G of x and p of x. When x is there in parenthesis, it is a function that we can consider. Okay, because see what is it saying, that functions, these are the functions of the independent variable x, especially when the nature of the function is unknown or unspecified. Okay, whatever the function is, nature of the function is, that is unknown to us, and at that time what we consider is the g of x and p of x, like f of x also, in addition to f of x. Okay, when x is there in parenthesis, it is known as the function. Okay, a function is a relation that maps each element x of a set A with one and only one element y of another set B. Same case, a function is a relation that maps each element of x, each element x of set A. Set A and is a function of set, set B is a function of set A here, and x is the x elements are of set A and y elements are of set B. In other words, it is a relation between a set of inputs and a set of outputs in which each input is related with a unique output. As we already have discussed, every x will have a unique value of y, that is nothing but f of x. So what it is called as, it is a relation between set of inputs. Here x is said to be the set of inputs, and this y is said to be a set of outputs. Okay, and for x there will be unique value of y. Set of x is A and set of y is B. Okay. Then it is a relation between a set of inputs and outputs in which each input is related with a unique output. Okay. Unique output is there for each input. A function is a rule that relates an input to exactly one output. Okay, what is that? A function is a rule that relates an input to exactly one output. Okay, input to exactly one output means again the same concept that for every x a unique y will be there. Then some common functions, for example, we can take as many widely used mathematical formulas are expressions of known functions. For example, the formula for the area of circle A is equal to pi r square gives the dependent variable A as the function of independent variable r. As r is going to change, A is also going to change, means the radius of the circle is going to change, area is also going to change. Okay. Functions involving more than two variables called multivariable or multivariate functions also are common in mathematics, as can be seen in the formula for area of triangle. Okay, what the area of triangle is? BH by 2 means breadth or base here, base and height. Okay, two variables are there. B for base is there and H is height there for the triangle, and multiplication of base and height divided by 2 gives us the area of triangle. If only one variable is there which is changing, that is nothing but the area of circle. But in case of area of triangle, what it is, two changing variables are there. One is base and one is height. And according to that, area is going to be changed. In this example, physical constraints force the independent variables to be positive numbers. Yes, means when we are considering the radius, it is always a positive number. Or when we consider base of the triangle and height of the triangle, all these are the positive numbers because we count in positive ways. When the independent variables are also allowed to take on negative values, thus any real number, the functions are known as real valued functions. Okay. What this sentence meaning is, when the independent variables are also allowed to take on negative variables. Okay. Hey, what we are saying here is the real numbers functions. Okay, area of circle, area of triangle. These are positive numbers always. We do not take the height of the triangle as -2, etc., etc. Okay, we take it as positive real numbers. When the independent variables are also allowed on negative values. Independent variables are like that. Here we can take that as negative values also, if we consider only the independent variables. Thus, any real number, the functions are known as real valued functions. Means all these are the real valued functions here. Area of circle, area of triangle, like that. Okay, these are known as real valued functions. Next is complex functions. Okay, you may have gone through this complex number uh, uh, topic in the mathematics. So complex functions, when we include that uh, complex number in the function, that function will be known as complex function. Okay, means here what will be there? What the complex number I is equal to square root of -1. Here it is given. So practical applications of functions whose variables are complex numbers are not so easy to illustrate, but they are nevertheless very extensive. Means what? They are not so easy to illustrate, but they occur. Okay, they occur, for example, in electrical engineering and aerodynamics. Okay, in complex functions are there in case of this electrical engineering and aerodynamics. If the complex variable is represented in the form of z is equal to x plus iy, when I is imaginary unit, the square root of -1, and x and y are real variables, it is possible to split the complex function into real and imaginary parts. Okay, what the real part is? F of z, p of xy plus I q of xy. Okay, what this I is? I is here the square root of -1, that is complex number. Okay, so these two functions are supposed there. This one is real part, p of xy, real variable, and q of xy, it is attached with the complex number, that is I, that is square root of -1. So it is the complex part. And from that, what we are going to evaluate is f of z, function of z. These are known as complex functions. Then we already have seen these multivariable functions and complex functions. Still, we have this list of types of functions that we are going to see one by one. Here, the first type is one-to-one function. Okay. Now, what is there in one-to-one function? A function f from a to b. Okay, a function f from a to b is one-to-one if this function is one-to-one if for each element of a there is a distinct element of b. It is also known as injective. Consider if a1 belongs to a and a2 belongs to b, f is defined as here like f from a to b such that f of a1 is f of a2. Okay, here we can see one-to-one function. A and B are the two sets there. Only one function is there, means A1 is assigned to B1 only, means only one element of B there. Then A2 is here assigned to B3 only. A3 is assigned to B2 only. A4 is assigned to B4 only. This type of function is known as one-to-one function. Only means one element of first set is assigned to one element of B only. Okay, second set means only one-to-one mapping is there. Anything it will be means A1 is assigned to B4 also. But if it is A1 is assigned to B4, then it will not be assigned to B3, B2 and B1. Only B4 will be there. Like this, one-to-one functions are there. Then many-to-one functions are there. Okay. It is a function which maps two or more elements of A to the same element of set B. Two or more elements of A have the same image in B. Like this, we can see here. Many to one function. A1 is also assigned to B1. A2 is also assigned to B1. Okay. Many from first set and one from second set. It is known as many to one function. Okay. And A3 is assigned to B3, only one function. But for this A1 and A2, it is the many to one function. Okay. See here what I have told you. One value of X will have unique value of Y. Okay. One value of X will have unique value of Y. Here means what? A1 is not having value B1 and B2 at a time. Okay. A1 is having only one value, that is B1. A2 is also having one value only, that is B1. But A1 at a time is not having B1 and B2 same value. Okay. This is the difference. Many to one function. Okay. Many from first set and one from second set. That is known as many to one function. Then onto function is there. Now what this onto is, if there exists a function for which every element of set B there is or there are pre-images in set A, it is onto function. Means what we can see here. A1 is assigned to B3 and A2 is assigned to B1 also and B4 also. Okay. A2 is assigned to B1 also and B4 also. Here what the type of this is, onto function. Okay, A3 is assigned to B2 and A4 is assigned to B5. If there exists a function for which every element of set B there is a pre-image in set A, means each element is assigned here in set B, each element is assigned. It is not here in the this many to one, means any element from B can be remain there because no any pair is there from A. Okay. But what is in onto function? All the elements of B are assigned with all the elements of A. Okay. Any one element it can have. Like A2 is having B1 and A2 is having B4 also. Okay. This type of function is known as onto function or surjective function. It is known as surjective function. Okay. Next type is one-to-one and onto. If both are there, one-to-one and onto, then that function is known as bijective function. What is there here we can see. A function f is one-to-one and onto or bijective if the function f is both one-to-one and onto function. In other words, the function f associates each element of A with the distinct element of B, and every element of B has a pre-image in A. Onto function, how it is? Every element of B is having pre-image in A. Means what? Every element of B is assigned with the help of every element of A. Okay. All elements of B are covered. B1, B2, B3, B4. So it is on to function. Okay. Then how one-to-one is here? In other words, the function f associates with each element of A with distinct element of B. Okay. A1 is also means here. A1 is associated to B4, A2 is associated to B3, A3 with B2 and A4 with B1. Okay. Distinct elements are there. Means like in one-to-one functions. A1, B4. How the pairs are there? A1, B4, A2, B3, A3, B2, and A4, B1. Like these, the pairs are there. And these B1, B2, B3, B4, all are here covered with the assignment of elements of A. So as all the elements of A1 are assigned with distinct element of B, it is one-to-one function, and all the elements of B are covered, so it is a onto function. As it is one-to-one and onto, both the functions are there, so we can call it as a one-to-one and onto function or bijective function. One single word for that is bijective function. Okay, because for one-to-one we use the word injective, for onto we use the word surjective, and if both are there, then we call it as bijective function. Okay, A and B, all the elements are assigned one-to-one, and elements of B are covered with the elements of A. So here we can take it as a bijective function. The next type of function is constant function. Okay, what constant function is, we can see here with the help of graph also. If the function f from R to R is defined as f of x is equal to y is equal to c, for x belongs to R and c is a constant in R. R is set of real numbers. Okay, for any value of x, same y is there, then that function is known as constant function. Okay, what it is saying that if any for any value of x, same y is there, then that type of function is known as constant function. Here and R is real number. Okay, R is set of real numbers, then such a function is known as constant function. The domain of the function f is R, that is set of real numbers, and its range is a constant, that is nothing but c. Plotting a graph, we find a straight line parallel to x-axis. Here we can see this is the x-axis. For any value of x, y is same, that is nothing but 3.5 here taken for the example, and so we can see it is a straight line which is parallel to x-axis. Okay, it is known as constant function. Okay, next is the identity function. What identity function is? Let R be the set of real numbers if the function f from R to R is defined as f of x is equal to y is equal to x. Okay, for x belongs to R, then the function is known as identity function. For identity function, what is there? X and y values are same. Okay, x and y values are same. Means for x equal to 1, y is also 1. For x equal to 2, y is also 2. 3, 3, 4, 4, 5, 5, 6, 6. Here we can see. Then the function is known as identity function because x is same as y. For f of x, it is not going to change the value of x. The domain and the range is same, that is R. The graph is always a straight line and passes through origin. It is also passes through origin because x equal to 0, y equal to 0. Same values are for x and y. So what it will be? It will be a straight line here. Okay. F of x equal to y equal to x. How is it given? f of x equal to y equal to x. You can see here x equal to 2, y equal to 2, 3, 3, 4, 4. Okay, so this function will be known as identity function. Next is quadratic functions. Now we know the functions, the quadratic equations and polynomial equations, like that. What the quadratic equations are? If the degree of polynomial function is 2, then it is a quadratic function. Okay, x square, and we have seen the quadratic equations like in schools also. Means x square minus 2x plus 4 equal to 0, like that. Those functions are known as quadratic functions. Okay, those equations are known as quadratic equations. And if we take them with the help of functions, then those are known as quadratic functions. Here it is expressed as f of x equal to ax square plus bx plus c. Okay, as I already told you, x square plus bx plus c, where a is not equal to 0. If a is 0, then will it be the quadratic equation? No, because 0 multiplied by any number, it gives 0. As we want a quadratic equation or quadratic function, so a must not be 0. So this type of function is known as quadratic function, where a is not equal to 0 and a, b, c are constants and x is variable. X is variable, a, b, c are the constants. The domain and the range are R. Okay, for any values we take the values of x square, means this function x square plus bx plus c, f of x is going to be changed for every value of x, but both are the real numbers. Okay, both will be, means x is real number, f of x also will be real number. So domain and range will be from a set of real numbers. The graphical representation of a quadratic function, say f of x is equal to x square minus 4 is, okay. For example, function taken here is x square minus 4. So f of x equal to y equal to x square minus 4 when we take the value of x as minus 4. Okay, minus 4 and its square is 16. 16 minus 4, it gives the value of f of x as 12. We can see here, for minus 4 value of x, we can go for this. Yes or no? Then if we consider value minus 2, okay, then minus 2 square, it's a 4. 4 minus 4 is equal to 0. So for this value of x as minus 2, y will be 0. Y is nothing but, yes, y is nothing but f of x. Okay, we are plotting the graph for this function x square minus 4. What if we take 0, x as the 0, 0 square minus 4, 0 square is 0, so minus 4 will be the value of f of x. When x is 0, minus 4 is the value of this f of x. Same case, when considered the value of x as 2, 2 square minus 4, it gives 0. So when x is 2, f of x is 0. Same case, when x is 4, f of x is 12 again. So here we took these 5 points, 12, 0, minus 4, 0 and 12. and the graph came like this. Okay, quadratic equation graph comes like this. Okay, this is known as parabola. Okay, the type of this what we can say shape is like parabola. So this is for a graph of quadratic functions, it is a parabola. Next is cubic functions. As quadratic functions are having degree 2, cubic functions will have degree 3. A cubic polynomial function is a polynomial of degree 3 and can be denoted by f of x is equal to ax cube plus bx square plus cx plus d, where a is not equal to 0 and a, b, c, d are constants and x is a variable. Graph for f of x equal to I equal to x cube minus 5. The domain and range are real numbers, as we have already discussed. Means values of x are real numbers, then values of f of x also are the real numbers. Example taken, cubic equation is x cube minus 5. When we can consider here, considered the minus 3 as x, then what we get it like minus 3 cube minus 5. What will be the cube of minus 3? Minus 27. Okay, minus 27 minus 5, the value will be minus 32. So here it comes the point. Then same considered for this one, minus 2. When minus 2 x equal to minus 2, what value is coming for minus 2 cube is minus 8, and minus 8 minus 5, what it becomes like minus 13. So the points come somewhere here. Then considered with the help when minus 1 is there. Okay, value of x is minus 1. Minus 1 cube is itself minus 1, and minus 1 minus 5, it gives the value of y as minus 6. Okay, so here the point comes minus 6. Okay, somewhere in between this line and this line, minus 6 comes here. Then for 0 cube minus 5, here it is coming means minus 6 and minus 5 point is here, somewhere here. Then when 1 is considered, what the value is? 1 cube minus 5, that is 1 minus 5, it is giving minus 4. This is the point somewhere here. Then 2 cube minus 5, what is the 2 cube? 8 minus 5, it is giving 3. So between 0 and 10, somewhere here is the point, that is 3. And what the last one is? Considered 3 cube minus 5. What the 3 cube is? 27. 27 minus 5 is equal to 22, and 22 is somewhere here. Okay, so when x is 3, y equal to f of x equal to 22 is there. So the graph comes like this. Means here it is gradually increasing, and when 0 is there, means when values are near to 0, x values are near to 0, then somewhat linear, means very small difference is there. If we consider when values are near 0. Okay, this type of graph is for cubic functions. You can take any cubic functions. The graph will be somewhat like this only. Okay, this is nothing but the cubic function. Then exponential functions. What is there in exponential functions? We can see the exponential function is a relation of the form y equal to a raised to x. Okay, with the independent variable x ranging over the entire real number line as the exponent of a positive number. Okay, x is varying quantity, means a is constant and suppose a square is there, a cube is there, a raised to 4 is there, a raised to 5 is there. That type of function is known as exponential function. Okay, exponent is there for a constant number a. Probably the most important of the exponential function is y equal to e raised to x. Okay, the exponential function we consider which is most important is nothing but e raised to x. We have seen in many examples that exponential function is considered as e raised to x. Okay, sometimes written as y equal to exp of x. Exp of x means what? E raised to x. Is here stands for exponential functions. Value of which that is 2.7182818 and dot dot dot. It may is the base of the natural system of logarithms. Okay, if natural logarithms we consider, then base of that logarithm is e. Okay, then if we consider binary logarithm, then logarithm base of that logarithm is 2. If we consider decimal logarithm, then base of that logarithm is 10. Okay, like if we consider the natural system of logarithms, there we consider the base of that logarithms is e and its value is 2.718 dot dot dot. Okay, as we have fixed value for pi, e is also having fixed value, that is 2.718. By definition of x is a logarithm, and there is thus a logarithmic function that is inverse of the exponential function. Okay, always we have the inverse of logarithm function is the exponential functions. Both are the operations which are opposite to each other. Okay, we specifically what we can say here is y equal to e raised to x. If this is the function y equal to e raised to x, then x is equal to logarithm y. Okay, if y equal to e raised to x is there, then x is equal to logarithm y. We can take the value like this. Okay, non-algebraic functions such as exponential functions and trigonometric functions are also known as transcendental functions. Okay, these are non-algebraic functions, exponential functions, trigonometric functions again contain sine, cos, tan, cot, sec, cosec. Those type of functions are known as transcendental functions. The next are polynomial functions. Okay, we have already seen quadratic polynomials and cubic polynomials. Okay, those are of degree 2, means quadratic are degree 2, cubic are degree 3. What these polynomial functions are there, we can see. A polynomial function is defined by y is equal to a0 plus a1x plus a2x2 plus dot 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 anxn. What is there? We can see here for all the values now, where n is non-negative integer. Okay, n is what? Non-negative integers. Means we are considering positive integers only. A0, A1, A2, N are belonging to R. R means again set of real numbers. Okay, but N is what? N is non-negative real number. The highest power of expression is the degree of the polynomial function. The highest power in the expression is the degree of polynomial function. Here the degree of polynomial function is 1. We are we are not able to see here any square or cube or something like that. Okay, so here degree of polynomial function is 1. Polynomial functions are further classified based on their degrees, like we have seen already, quadratic and cubic also. In that, constant is there. If degree is 0, the polynomial function is constant function. That also we have seen. One straight line was there which was parallel to x-axis. That is nothing but constant function. And what the linear function is? Here the polynomial function with degree 1. Okay, that is known as linear function. Y equal to x plus 1. x ची डिग्री 1 आहे इथं. स्क्वेअर क्यूब किंवा रेज टू 4 रेज टू 5 असं काही नाहीये. y equal to x plus 1 or y equal to x or y equal to 2x minus 5 etc. are the linear functions. Okay, means linear functions are having degree 1. Okay, x ची डिग्री काय असणार आहे? 1 असणार आहे in case of linear functions. Okay, if it is 0, degree of that polynomial function is 0, then it is a constant function. If degree of polynomial function is 1, then it is a linear function. If degree of polynomial function is 2, it is quadratic function. If degree of polynomial function is 3, then it is a cubic function and so on. Okay. The polynomial function with degree 1, these are the examples. Taking into consideration y equal to x minus 6, the domain and the range are R. Real numbers are, means both are, means x is real number, y is also the real number. The graph is always a straight line. For linear functions, graph is always a straight line. Here we can see the function taken here is x minus 6. For the values of these values of x, these values of y are there. That is nothing but f of x. If x is minus 4, then y is minus 10. Minus 4 minus 6, it is minus 10. If x is minus 3, then it is what? Minus 3 minus 6, it's minus 9. Then if x is minus 2, then minus 2 minus 6, it is, yes, it is minus 8. Here we can see value of this minus 8. Then minus 7 will be there. Value of x is minus 1. So minus 1 minus 6, it is minus 7. Then if value is 0, if value is 0 for this x, then f of x will be 0 minus 6, that is nothing but minus 6. Like that, it is going to change the values of y. If we change the values of x, f of x equal to y, and the function taken was x minus 6. Okay, here for that the graph is plotted like this. This is nothing but the linear functions. In case of polynomial functions, then we have seen constant functions, linear functions, quadratic functions, and cubic functions. Okay. Then next type of function is modulus function. Modulus functions are there. The absolute value of any number C is represented in the form of mod C. Okay. Modulus function we know means if C is there, any absolute value, that is any number, it is represented in the form of mod C. If any function from set of real values is defined by f of x equal to mod x, it is known as modulus function. For each non-negative value of x, f of x equal to x, and for each negative value of x, f of x is minus x. Okay, that is f of x is x if x is greater than 0, and it is minus x if x is less than 0. Means what? Here we can see here x is negative, here less than 0, minus 1, minus 2, minus 3, minus 4, and here it is 1, 2, 3, 4. How the values are given here? X is less than 0. What the value of minus 4 is? 4. Absolute value we have to take here. For mod of minus 4, we have value 4. Mod of minus 3, we have value 3. Mod of minus 2, we have value 2. For mod of minus 1, we have value 1. And for mod 0, again its absolute value is 0. Same, mod of 1 is 1. Mod of 2 is 2. Mod of 3 is 3. Mod of 4 is 4. So like this, the function graph comes like this here. Okay. It is the type of graph. It is known as modulus function. When we consider the value of means for negative values, we take the absolute value when we consider the mod of that. Okay. X is when minus 4, mod of minus 4 is nothing but 4. Okay. We have to consider here mod values, and if it is considered, then that function is known as modulus function. Okay. And we can see here both means domain and range both are from a real number set only. Okay. It is a modulus function. Then next type is rational function. Okay. What now the rational function is there? A rational function is any function which can be represented by a rational fraction, say f of x divided by g of x, in which numerator f of x and denominator g of x are polynomial functions of x. Okay. Here f of x and g of x, what are there? F of x and g of x. Numerator is f of x, denominator is g of x, and these are the polynomial functions of x. These are the polynomial functions of x, and where g of x is not equal to 0, because we know if denominator is containing 0, then if g of x is 0, that is denominator is 0, then the answer coming is infinity, and which is not possible. So here what the condition is? G of x is not equal to 0. Let a function f r to r, from r to r is defined, say f of x is equal to 1 upon x plus 2.5. Okay, here f of x is 1, f of x is 1 and g of x is x plus 2.5. The domain and the range are R, means all the values are from real numbers. So domain and range both are from real numbers. The graphical representation shows asymptotes, the curves which seem to touch the axis lines. Okay, here these type of curves are known as asymptotes. I don't know, have you gone through these terms, because in M2 it consists asymptotes. Okay, these type of curves are there as a part of syllabus in M2, that is mathematics 2. Here what we can say is 1 upon x plus 2.5. F of x is given as 1, that is constant function is given, and in denominator x plus 2.5 is there. So evaluated for these values of x, that is -10, -5, 0, 5 and 10, then these points are taken into the account, means whatever the values of for x equal to 10.5, it came like this. Okay, in case of -5, it came like this. Okay, then when 0, what about 0? 1 upon 0 plus 2.5, means 1 upon 2.5 value with something near to 0 will be there. Okay, then when considered as 5 and when considered as 10, here the values are coming there. Okay, so here is the graph plotted for these rational functions. When we consider the rational functions, again like rational numbers, two functions are there, one in numerator and second in denominator. Then the I think second last uh, uh, type of function is sinum function. What is sinum function now? If function f is from real numbers to real numbers defined by f of x is 1 if x is greater than 0, and 0 if x equal to 0, and -1 if x is less than 0. Okay, here we can consider that type of function is known as sinum function. If x value is 0, y value is also 0. If x value is less than 0, that is negative, always y value is -1. Okay, always value of y is -1. And if x is greater than 0, then it is always 1. Y value is always 1. This type of function is known as sinum function. Okay, what the function is known as sinum function. Here we can see f of x is 1 when x is greater than 0. Here x is greater than 0. Then f of x equal to 0. If x is 0, then f of x is also 0. And if f of x is -1, then x here is the negative number, that is less than 0. Graph for that function will be like this one. Okay, when the values are greater than, x values are greater than 0, then +1 is the value. When negative values are there for x, this -1 value is there. Any function will be there. Okay, and then if x is 0, then y is also 0. Y is nothing but f of x. Signum or the sign function extracts the sign of the real number and is also known as the step function. Okay. Why the step function again? Yes. Because it is derived from whatever we call it as, uh, means whatever will be the value of x, if it is less than 0, then y value will be -1. And if x value is greater than 0, then y value will be 1. And if x is 0, y is also 0. Okay. This type of function is known as signum function. The next is greatest integer function. Okay. Now, what this greatest integer function deals with? Round off values. Okay. Round off values means, suppose here taken, for example, -21 as 21, 5.12 as 5. We take the round numbers, or we take the solid numbers when considered the numbers like this having points 5.12, etc., etc. Okay. The round off to the real number to the integer less than the number. Okay. uh, Suppose the given interval is in the form of k plus 1. The value of greatest integer function is k, which is an integer. Okay. The given interval is in the form of k and k plus 1. Okay. The value of greatest integer function is k, which is an integer. K is the constant that we know. For example, here for -21, we can write it like 21. For 5.12, we can write it like 5. The geographical representation is like this. We can see here. For -4, 4 is there. Minus, here values are, x values are not uh, uh, here 4. It is 0. Okay. So it will be -3, -2, -1. Here it will be -4, -3, or -3, -2, -1, 0, 1, 2, and 3. Okay. So the we are considering here the absolute values. Means for minus values, these plus values will be there. Okay. Greatest integer function. This type of function will be known as greatest integer functions. Okay. All these are the types of functions those we have seen. Just have a look. In that we have seen complex functions, one to one, many to one, on to one to one, on to, then constant functions, identity functions, quadratic functions, cubic functions, exponential functions. In polynomial functions, again there are types of polynomial function: constant function, linear function, quadratic and cubic functions. Then modulus function, rational, signum, greatest integer functions. Like these, all the types of functions we have seen. Next bit we are going to see is composition of functions. Okay. First tell me, all of you, have you got the functions of types? Sorry, types of the functions. It is a slip of tongue. Yes. Someone's camera is on. Mallar. No one is giving response, so I assume all of you have got the types of functions here. We will stop here today. Uh, Tomorrow we are having again one session, 2:30 to 3:30. In that session, we will take the next part of the lecture. Okay.
Okay, ma'am.
Just put your roll numbers in chat box. All of you put your numbers in chat box. Only once. Do not repeat. Okay, we can stop here.